All right, we start off with some examples, and then we get into some theory. Now, this is going to be one of those times where we are going to be able to do the problem without a formula, even though there is an associated formula for these. So we're just going to think about these. So this is a card one. So consider a standard deck of 52 cards. What is the probability of picking? Well, by me asking for a probability, I want a fraction, decimal, or percent. Fraction's the easiest here. Part A, picking a 7. So the numerator would represent the number of 7s in a deck of cards. 4. Denominator represents the total number of cards in a deck of cards. 52. Done. That does reduce to 1/13, which should make sense because out of the 13 values, there's only one of them is a 7. So you can think about it that way too. All right, a jack. How many jacks are in a deck of cards? Out of how many total cards? And as stated, that reduces down to 1/13. Good. This is great. You want 20 of these on your test. Part C, a jack or a 7 or a jack. Well, key word here is or. We have two major conjunction words, or and. We already saw that and, for the most part, means to multiply. Not always, but for the most part. Or, for the most part, means to add. So how many total cards in a deck are either 7s or jacks? 2/13, 8/52. So this is the probability of picking a 7, plus this is the probability of picking a jack. Add them together, and averages down to 2/13. So out of the 13 values, 2 of them are 7s or jacks. Good. So that's when or works nicely. But now let's do the next row. Probability of picking a queen. How many queens are in a deck of cards? Yep. How many hearts are in a deck of cards? Part E, 13 out of 52. What does that reduce down to? 4. At least you guessed. 1/4. But part F, a queen or a heart. Well, this is different. The reason it's different is because if we straight up added the 4 queens plus the 13 hearts, then we're double counting the queen of hearts. So whenever you have an or, you have to take out the cards, or in this case, the cards that overlap. So we have 4 queens. We have 13 hearts. But we have to take out the overlap. How many queen of hearts are there? 1. So in part C, there is no jack that is also a 7, so we did not have to subtract anything. In part EF, there is a card that is both a queen and a heart, so we can't double count it. What is 4 plus 13, then minus 1? Over 52. And that reduces down to 4/13. Hooray. So when you hear the word or it's implied, then you think addition. However, you have to worry about if there's an overlap, and you just take that overlap out.